Hello, PLP geometry. Welcome to the fourth lesson of Unit 4. So this is Unit 4. We are covering similarity and right triangles. This is actually going to be the last similarity-focused video. And this one is titled the Side Splitter Theorem. So video number 4 is called the Side Splitter Theorem. Okay, so we have been spending a lot of time on these similar triangles. So there's one kind of extension with the similar triangles, and it's called the side splitter theorem. So the side splitter theorem. And it conveniently does what it says, right? So here's the idea, right? So if a line, and it's probably going to be a segment, but we say line, if a line is parallel, so there's that word parallel, right? We should know parallel from previous lessons, to one side of a triangle. Let me see what the, yeah, that's probably better font, sorry. Let me erase that, of a triangle. So if a line is parallel to one side of a triangle, then it divides the other two sides proportionally. Two sides proportionately. Proportionally. There you go. Proportionally? I don't know. One of those words. Proportionally. All right, very good. So the idea here is we have a triangle. Let's call it triangle ABC. All right, here's triangle ABC. Now, I'm going to draw a segment in this triangle, and it's going to be parallel to AC. So I'm going to draw it right here. Now, purposely, I'm not going through the middle of the side, so please don't do that. We'll do that in a second. And let's call this M, and let's call this N. And let's say that these two are parallel. So the idea here is if we know that segment MN is parallel to AC. So if this line is parallel to the third side, or to a side of the triangle, then it's going to split these two sides proportionally. Now you can see how the two sides on the left and right are broken into two segments. So we can set up a proportion then, and we can say AM, so AM, the smaller part, over MB. Notice those two segments make up the left-hand side equals, and now we create the second fraction in the same proportion. Let's do CN, the small part, over NB. Okay. Or we can go from the top to bottom. We could do BM, the big part, over MA equals, and now go to the other side. We could do BN, the big part, over NC. Either of these proportions will work. We set these proportions up, or this proportion up, and we solve for the unknown. Side splitter theorem. Okay, so now we have two special cases that we're going to talk about that involve the side splitter. So a special case. Special cases. The first one here is called the triangle mid-segment. Okay. Now, with a triangle mid-segment, again, that word mid, think of midpoints. So again, I'll draw that triangle ABC, just like we had before. But now, A, B, C. But now let's put M and N right in the middle. So M is the midpoint of AB, so congruent markings here. N will be the midpoint of BC, so double markings here, and there we go. There is segment MM. So in this case, with a triangle mid-segment, that means that M and N, the segments that make that parallel side, right, are midpoints. And again, these two are still parallel, and it just breaks the sides into equal parts, right? So it's a 1-to-1 ratio because AM is equal to BM, and same thing on the right hand side. Okay, and then the last special case here, right? Number 2 special case is with 3 parallel lines. 3 parallel lines. So in this case here, we're not going to have a triangle. So we're going to have 3 parallel lines. So 1, 2, 3. And call these lines L, M, and N. And I'm going to draw 2 transversals. One like that, and one over here like this. There we go. And let's call this intersection point A. Let's call this intersection point B. Let's call this intersection point C. And then back to the top, D and E and F. So this picture works just like the side splitter theorem, right? Imagine that the triangle was formed if we extended those 2 transversals and they met, right? So if we know that L is parallel to M is parallel to N, then, and we just work down a side. So then let's work down this transversal, then AB over BC is going to equal, and then go back to the other transversal, equals DE over EF. Right. Now, I'm not going to do any examples in this video. I think you can do these problems, but let's just make a little note, right? That once we create our proportions, remember the 2 steps are to cross multiply, and then once you cross multiply, you typically divide. And if you cross multiply and divide, you'll solve for your unknown length. All right, great. Okay, thanks for watching. Good luck on the practice.